Hi everyone, it's Professor West again, and we're going to cover 1.4 quadratic equations. So let's start with the definition. Quadratic equation. All right. Let A, B, and C be in the set of real numbers. So let A, B, and C be in the set of real numbers where A does not equal 0. Okay. Then a quadratic equation in the variable x is an equation of the form ax squared plus bx plus c equals 0. Okay, so that is the definition of a quadratic equation. Next, we're going to talk about the zero product property. Okay, zero product property. So let m and n be real numbers. Let m and n be in the set of real numbers, meaning they're real numbers. Okay? Then, if mn equals 0, so if m times n equals 0, then m equals 0 or n equals 0. That's an or. And this is an inclusive or. So this is an inclusive or. Okay? So what does that mean? Inclusive or. An inclusive or means that either m is 0 and n is not 0, n is 0 and m is not 0, or both m and n are 0 are all possibilities. All right. So next, we have a couple of examples to test out our zero product property. So let's try them out. So solve the following equations for x. So we have part A. X minus 2 times x plus 5 equals 0. X minus 2 times x plus 5 equals 0. So I'm going to rewrite the problem. All right, now if we remember our zero product property, If I have two things that are being multiplied together and they equal 0, that means one of them must be equal to 0, which means that x minus 2 equals 0 or x plus 5 equals 0. And now we're going to want to solve for both of these linear equations. So on the left we have x minus 2 equals 0. Well, I could add 2 to both sides. So I have x minus 2 plus 2 equals 0 plus 2, which means I get x equals 2. So there's an answer. Okay, on the right-hand side, let me move it over a bit so we have some space. I'm going to subtract 5 from both sides. So I get x plus 5 minus 5 equals 0 minus 5. So on the left, I will get x, and on the right, I will get negative 5. So for quadratic equations, you can have either one real solution, two real solutions like we have here, or two non-real solutions. And we got the two real solutions, which is the most common. All right, so that was part A. Let's do part B. Part B is 2x squared minus 4x equals 0. All right, so we want to factor. But to factor, we need to find the common factor of all of our terms. So take a second and pause the video and try to see if you can think of what the common factor is. I'll give you a second to pause now. All right, so you should have seen that both of the coefficients are even, which means that there is a 2 in the common factor, as well as both of them have at least one x. So 2x is the common factor. Now we have to see what we have left. So if I pull 2x out of 2x squared, I should end up with just x left over. And if I pull 2x out of negative 4x, I should just end up with negative 2. So I should have 2x times x minus 2 equals 0. Now again, we're going to use the zero product property. So now I have 2x equals 0, and I have x minus 2 equals 0. On the left-hand side, we're going to multiply both sides by 1/2. So I have 1/2 times 2x on the right, and I have 1/2 times 0 on over here. Okay, so on the left-hand side of the equation, we will just get x, and on the right-hand side of the equation, we will get 0. So we get x equals 0 as one of our answers, so we will box that in. All right, on the right-hand side, we just need to add 2 to both sides. So I'm going to go x minus 2 plus 2 equals 0 plus 2. On the left, that will leave us with just x, and on the right, that will leave us with 2. So x equals 2. And so the solutions are x equals 0 and x equals 2 for part B. We're going to move on now to part C, which requires us to use factoring by grouping. So I will help us remember how to do that. So we have 6x squared plus 7x minus 5 equals 0. All right, I'm going to rewrite it. 6x squared plus 7x minus 5 equals 0. So we're going to have to factor by grouping. So how I do it is I draw a giant X first. So I'm going to draw my giant X here. And we're going to want to put A times C up here, and we're going to put B down here. So what is A times C? Well, if we recall, this is A, this is B, and this is C. So A times C is going to be 6 times negative 5. 6 times negative 5 is negative 30. So I'll put a negative 30 in the top part of my X. And then we put B in the bottom part. So this helps us try to figure out two numbers that will add to give me 7 that will multiply to give me negative 30. Pause the video now to see if you can think of two numbers that will add to give me 7 and multiply to give me negative 30. Pause now. Okay, so after trial and error, you should have found that the two numbers are 10 and negative 3. 10 plus negative 3 is 7, and 10 times negative 3 is negative 30. So we're going to use these two numbers here. We're going to use these two numbers here, and we're going to replace them. We're going to replace them with the 7 as such. So I'm going to go 6x squared plus 10x minus 3x minus 5 equals 0. Notice all I did was replace the 7x with 10x and negative 3x. That's all I did. All right? So now we're going to factor by grouping. So to do that, we first have to put our first two terms in parentheses. So 6x squared plus 10x. And then we want to put our second terms in parentheses. I'm going to leave a little space here. Negative 3x minus 5 equals 0. So between the two, we want to put a plus sign because all we really want to do is just add parentheses. So we want to make sure that it still reads the same as the line above. So this plus sign right here will make sure that it reads the same. Okay, so now we want to pull out all common factors. We just want to factor these two. So on the left-hand side, the common factor between 6x squared and 10x happens to be 2x. So I'm going to pull out a 2x. 2x. So what does that leave me with? Well, over here with the 6x squared, that will leave me with 3x. And then when I pull 2x out of 10x, that will leave me with a plus 5. Bring down my plus sign. On the right-hand side, what can I pull out? It looks like the only thing I can pull out is a negative 1. So I'm going to pull out a negative 1. So I'm going to be left with 3x plus 5. And then everything equals 0. Now, you know you did this right if you get the same answer in your parentheses. If those are the same, you know that you did it right. So you might want to make a note of that. If those are the same, you did it right. So now we're going to pull out our 3x plus 5. So I'm going to pull out my 3x plus 5. So 3x plus 5. And now we want to see, well, what are we left with after we pull out 3x plus 5? I'm left with a 2x and a negative 1. So in my other set of parentheses, I'm just going to write what I'm left with, which is 2x minus 1. That equals 0. Now we can finally use the zero product property now that I have two things here that are multiplied together that equal 0. So I have 3x plus 5 equals 0, and I have 2x minus 1 equals 0. So for 3x plus 5, we're going to just want to subtract 5 from both sides. So I have 3x plus 5 minus 5 equals 0 minus 5. So on the left-hand side, I get 3x. And on the right-hand side, I get negative 5. Now we're going to want to multiply both sides by 1/3. So 1/3 times 3x, equals 1/3 times negative 5. One-third times 3x should just leave us with x. I'm going to kind of put it down here. And 1/3 times negative 5, you can pretend that it's over 1 if that helps. That will leave us with negative 5/3. So we get x equals negative 5/3. That's our final answer for here. But we have a second final answer over here, so let's not forget about it. I'm going to move it over a bit so we have room. So our first step on the second equation is to add 1 to both sides. So I'm going to go 2x minus 1 plus 1 equals 0 plus 1. On the left-hand side, you're just going to be left with 2x. On the right-hand side, you're going to be left with 1. Now we want to multiply both sides by 1/2 to get rid of that 2. So I'm going to go 1/2 times 2x equals 1/2 times 1. So on the left-hand side, 1/2 times 2x is just going to give us x. So I'm just going to put a little space here. X equals 1/2 times 1 is just 1/2 because 1 times anything is that thing. So x equals 1/2. So our answers are x equals negative 5/3 and x equals 1/2 for part C. The most important part about this part is that we factor, okay? So you might need to practice factoring. You might need to practice factoring if you're struggling with it. Feel free to come into office hours, go to the tutoring center, or look up some videos on YouTube or Khan Academy. I'm always here to help you, and I know factoring might be something that we have forgotten. So if you need any help, just let me know. All right. So those were the 3 examples. We're going to move on to the square root property. Okay. So, the square root property. All right. It simply states if x squared equals k, then x equals plus or minus the square root of k. If x squared equals k, then x equals plus or minus the square root of k. So let's do an example. Solve the following equations for x. Okay. All right, part A. Part A is x squared equals 25. X squared equals 25. So if we remember from up here, if x squared equals some number k, then x equals plus or minus the square root of k. So here we have x squared equals 25. Following the square root property, that must mean that x equals plus or minus the square root of 5. Or the square root of 25, my bad. But what is the square root of 25? Well, as you just saw from my little mistake there, that means that x equals plus or minus 5, because the square root of 25 is 5, and you feel free to use your calculator for that. All right, so we're going to want to write our answers, though, as x equals 5 and as x equals negative 5 as separate boxed answers here. That's how we want to make sure we're writing our answers for these. So that's how we do the first one. All right, I have another one for you. Part B. Part B is 9x squared minus 36 equals 0. So if we want to use the square root property, we're going to want to get x squared equals something, meaning we want to get x squared by itself. So how can we get x squared by itself? First, let's rewrite the problem. Well, I'm going to add 36 to both sides. So I'm going to get 9x squared plus 36, 9x squared minus 36, but I'm adding 36 to both sides, equals 0 plus 36. All right. On the left-hand side, the 36's cancel, and we get 9x squared equals 0 plus 36 is 36. Now, we're going to want to get rid of that 9. So I'm going to multiply both sides by 1 over 9. So 1 over 9 times 9x squared equals 36 times 1 over 9. So 1 over 9 times 36. On the left-hand side, that will give us x squared. On the right-hand side, that will give us 4. All right, so now we can use the square root property. The square root property just said if x squared, let's see if I can write here, if x squared equals k, then x equals plus or minus the square root of k. So here we have x squared equals 4. So that means that x equals plus or minus the square root of 4. Now what's the square root of 4? If you put in your calculator, it's 2. So x equals plus or minus 2. Now to write our final answer, we're going to want to write them separately. So we're going to want to write x equals 2, like this, and x equals negative 2, like this. And then we're done. All right, let's try one more. Part C. Part C, I have x minus 10 squared plus 3 equals 52. So in this circumstance, we have a quantity squared, not just x, but we can still use our square root property. So let's see how. instead of trying to get x squared by itself or just x by itself, we're going to try to get x minus 10 squared by itself. So let's rewrite the problem. So I'm going to go x minus 10 squared plus 3 equals 52. First thing I want to do is get x minus 10, the quantity squared, alone. So I'm going to subtract 3 from both sides. So I'm going to get x minus 10 squared plus 3 minus 3 equals 52 minus 3. So on the left-hand side, I'm going to be left with x minus 10 squared equals 52 minus 3 is 49. So now, instead of having x squared equals a number, we have a quantity squared equals a number, but we can still do the same thing we did before. And I'm going to move this over just so our equal signs line up. All right, so instead of just having x equals plus or minus the square root of 49, we're going to have x minus 10 equals plus or minus the square root of 49. And now we're going to figure out what the square root of 49 is. It's 7. So we're going to have x minus 10 equals plus or minus 7. And now here's why splitting it up is very important. Because I'm going to have x minus 10 equals positive 7 over here, and x minus 10 equals negative 7 over here. And we're going to want to solve for x on both of them. So see how splitting this up has made it easier for us. So on the left-hand side, I'm just going to add 10 to both sides. So I'm going to get x minus 10 plus 10 equals 7 plus 10. So on that left-hand side, I get x. And on that right-hand side, 7 plus 10 is 17. So our first answer is x equals 17. Now on the right-hand side, I'm going to add 10 to both sides again. So I have x minus 10 plus 10 equals negative 7 plus 10. So on that left-hand side, I'm going to get x. And on that right-hand side, negative 7 plus 10 is 3. So I get x equals 3. And there we have solved for x. And again, like I said, splitting after this step is important. So make sure you do that. All right, let's talk about the complete the square method. Now, you want to make sure that you know how to complete the square, because on an exam, it could ask you, hey, solve for this quadratic equation using complete the square. And if you use a different method, you will not get all your points. So you want to make sure you know how to complete the square. So, complete the square method. Complete the square method. So, any quadratic equation, this works on all quadratic equations. So, any quadratic equation, I'm going to move over to the middle so we have more room to write. Ax squared plus bx plus c can be rewritten as a perfect square that can be factored to use the square root property. Okay, I'm going to write out the steps for completing the square. Now you did see this in your book, but I actually changed the steps a little bit to make them a little bit easier for everyone. So here are the steps for completing the square. Steps for completing the square. Okay. To solve, ax squared plus bx plus c equals 0. Via completing the square, use the following algorithm. And I have some steps for you. Step 1. Multiply both sides by 1 over a. Okay. Step 2. Isolate the variables on one side of the equation. Step 3. Find b over 2 squared. Find b over 2 squared. Step 4. Add b over 2 squared to both sides. Five. Factor the resulting polynomial. We have a hint for this one. Hint. It will always be factored as the quantity, underline hint here, the quantity of x plus b over 2 squared. Okay? And step 6, use the square root property to solve. And these are the steps for completing the square. And these are very important. But don't worry, we're going to do an example. So let's follow along. Example. Solve 2x squared plus 6x minus 20 equals 0 for x using the completing the square method. All right, first thing I'm going to do is just rewrite the equation. So I have 2x squared plus 6x minus 20 equals 0. So our first step is, if we look up, is to multiply both sides by 1 over a. So in our problem here, a is 2. It's that first number in the front. That is a. So I'm going to multiply both sides by 1 over a. Oops, which is 2. So 1 over 2. So I get 1 over 2 times 2x squared plus 6x minus 20. And whatever I do to one side, I have to do to the other. So times 1/2 times 0. Let me make sure that I get this in the right color. All right. So we want to make sure that we're bringing our 1/2 through. So 1/2 times 2x squared is just going to be x squared. So I can now have x squared. 1/2 times 6x is just 3x. So plus 3x. And then 1/2, oops, 1/2 times negative 20 is negative 10. Equals 1/2 times 0 is 0. So that's step 1 done. Let's go look at step 2. Step 2 says isolate the variables on one side of the equation. So if we look down here, we can see variables here. X squared has x in it. 3x has x in it, so we want to get rid of the minus 10 because we want all of our variables on one side. So I'm going to add 10 to both sides. So I have x squared plus 3x minus 10 plus 10 equals 0 plus 10. So on the left-hand side, I'm just going to have x squared plus 3x. X squared plus 3x equals 0 plus 10 is 10. Okay, now let's move on to the next step. If we look up here, the next step is to find b over 2 squared. So let's make a little note to ourselves. So that's what we're doing. Find b over 2 squared. Okay. So to find b over 2 squared, we need to figure out, let me make it like this, maybe. We need to figure out what b is. So b, in our case, if we look up to the original problem, over here, b from this problem is 3. So b is 3. So that means that b over 2 squared is 3 over 2 squared, which is 9 over 4. So that 9 over 4 is going to be important because that is what we have to, if we look up at the next step, add to both sides. We need to add b over 2 squared to both sides, or add 9 over 4 to both sides. So if I bring my equation back down, our equation was x squared plus 3x equals 10. And now we're going to add 9 over 4 to both sides. So I'm going to get x squared plus 3x plus 9 over 4 equals 10 plus 9 over 4. So on the left-hand side, if we scroll back up here, on the left-hand side, we want to factor the polynomial, but we were given a hint. It will always be x plus b over 2 squared. But we know what b over 2 is. B over 2 is what's inside here. So it's 3/2. So when we factor, we know it's going to be x plus 3/2 squared. So this is x plus 3/2 squared equals, and now we want to get like terms. So 10 can turn into 40 over 4 to have a like denominator, plus 9 over 4. So now we can add those together, and we will get x plus 3 over 2 squared equals 40 plus 9 is 49 all over 4. All right, so now what we're going to do is finally we get to use the square root property. So we're going to take the square root of both sides. So I'm going to end up with x plus 3 over 2 equals plus or minus the square root of 49 over 4. Now, if you know anything about fractions and if there's a square root, that just means take the square root of the numerator and take the square root of the denominator. Or in other words, we now have, and we can drop the parentheses on the left-hand side, x plus 3 over 2 equals plus or minus the square root of 49 over the square root of 4. So the square root of 49, as we saw earlier, was 7, but first let's write this. X plus 3 over 2 equals plus or minus, and yes, the square root of 49, as we just said, is 7, and the square root of 4 is 2. Now we want to split up our problem. So we're going to split up our problem. So on the left-hand side here, let's do x plus 3 over 2 equals positive 7 over 2. And over here, let's do x plus 3 over 2 equals negative 7 over 2. So on this left-hand side, we're going to subtract 3/2 from both sides. So we're going to get x plus 3 over 2 minus 3 over 2 equals 7 over 2 minus 3 over 2. And on the left-hand side, we're going to get x, let me get it over here, x equals 7 minus 3 is 4 over 2, and that will reduce to x equals 2. So we have our first answer of x equals 2. Now we want to go over to this side, and we're going to, again, subtract 3/2 from both sides. So I'm going to have x plus 3 over 2 minus 3 over 2 equals negative 7 over 2 minus 3 over 2. And so then on the left-hand side, we're going to get just x equals negative 7 over 2 minus 3 over 2 gives us negative 10 over 2. So negative 10 over 2 reduces to x equals negative 5. So our final answer, via completing the square, is x equals 2 and x equals negative 5. And again, you're going to want to make sure you know how to use this method for an exam. Probably the most important part is remembering that you need to find b over 2 squared to know what to add to both sides. And you're going to also want to know that it will factor into x plus b over 2. All right. So that is completing the square. And completing the square works on every single quadratic equation. Something else that works on every single quadratic equation is the quadratic formula. The quadratic formula. The quadratic formula is found via completing the square, which is why both of them always work. So, the quadratic formula states for ax squared plus bx plus c equals 0, the solutions for x are, and we will get x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So for ax squared plus bx plus c equals 0, the solutions for x are x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's test it out. Example. Solve 3x squared minus 25x plus 8 equals 0 for x by using the quadratic formula. All right, so I'm just going to rewrite the equation here. So I have 3x squared minus 25x plus 8 equals 0. So first thing we want to do is figure out what a is, what b is, what c is, since that's what's important for up here. So a is 3, b is negative 25, negative 25, and c is 8. All right, so let's write the quadratic formula and then plug everything in. So remember, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's plug and chug. So now I will get x equals negative, and b was negative 25, so negative 25 plus or minus the square root of negative 25 squared minus 4 times a is 3 times c is 8 all over 2 times 3. Okay, so our next step here, negative 25, having these two negatives here, that makes a positive. So we have a positive 25 plus or minus the square root of negative 25 squared. If you put negative 25 squared into your calculator, you will get 625 minus 4 times 3 times 8. If you put that in your calculator, you will get 96 all over 2 times 3 is 6. Okay. So now we have x equals 25 plus or minus the square root of 625 minus 96 is 529. 529 all over 6. So the square root of 529, if you put that in your calculator, which you should, the square root of 529 is 23. So we get x equals 25 plus or minus 23 all over 6. And now all we have to deal with right now is this plus or minus. So we want to split up into two situations. Our first situation is going to end up being x equals 25 plus 23 all over 6. And our second situation will be x equals 25 minus 23 all over 6. Let's start with the left situation. So 25 plus 23, if you put that into your calculator, you will get 48. So we have x equals 48 over 6. 48 over 6 reduces to x equals 8. So our first answer is x equals 8. And we'll box that in. Our second Our second situation is 25 minus 23 over 6. So let's do 25 minus 23. So if I do that, I get x equals 2 over 6. X equals 2 over 6. And that reduces to x equals 1 over 3. So our answers using the quadratic equation for this are x equals 8 and x equals 1 over 3. So if we look at this problem here, the most important part is memorizing the quadratic formula. So you're going to want to have this memorized. It is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You want to have that committed to memory. All right. The last thing we're going to talk about is the discriminant. The discriminant. So, this is the part under the radical of the quadratic formula. Namely, oh my gosh, there we go. Namely, for ax squared plus bx plus c, the discriminant is b squared minus 4ac. All right. So now you're wondering, why the heck do we care? Well, note. The discriminant tells us how many and the type of solutions for a quadratic equation. Okay, so how does it do that? Well, we have a little chart that we're going to make. So, number and types of a quadratic equations. All right, so we're going to make a little chart here. First, we're going to have our discriminant. Oops, here. Okay, and then we're going to have the number of solutions. And then we're going to have the type of solutions. All right. Move that S a little over. There we go. So, first, if our discriminant, b squared minus 4ac, is greater than 0, that means you have two solutions and they are real solutions. So if our discriminant is greater than 0, there will be two solutions and the solutions will be real. Now, if b squared minus 4ac is less than 0, we will still have two solutions, but they will be non-real solutions or imaginary solutions made of complex numbers. So they will be non-real solutions. And then if b squared minus 4ac equals 0, we will only have one solution and it will be a real solution. So these are the three possibilities for your discriminant. So let's practice with them. Example. Determine the number and type of solutions for the following quadratic equations. Okay, part A. Part A is x squared plus 6x plus 9 equals 0. X squared plus 6x plus 9 equals 0. So we're just going to want to label what A is, B is, and C is. So A, B, and C, because all we care about is the discriminant. So A is 1, B is 6, and C is 9. Next, we want to plug them into the discriminant. The discriminant is b squared minus 4ac. So that's going to be 6 squared minus 4 times 1 times 9. All right. 6 squared is 36, minus 4 times 9 is also 36. 36 minus 36 is 0. So if we look back to see what 0 means, that's this one. 0 means that we have one solution and it's real. So our answer will be one real solution. One real solution. And that's my answer. Okay, part B. We have 2x squared minus 3x plus 5 equals 0. So again, let's figure out what A, B, and C are. A is 2, B is -3, and C is 5. So let's plug it in. So we have B squared minus 4AC. B is -3, so we have -3 squared minus 4 times 2 times 5. So -3 squared is 9 minus 4 times 2 times 5, if you put that in your calculator, is 40. So 9 minus 40 is -31. Now let's compare -31 to 0. Is it less than 0 or greater than 0? It's less than 0. Less than 0. So if we look back up, what does it mean if the determinant is less than 0? Well, that is this one. It means we have two solutions that are non-real. So we're going to want to say two non-real solutions as our answer. And that is our final answer here. Okay. And finally, part C. We have 2x squared plus 7x minus 1 equals 0. Again, we just want to figure out what A, B, and C are. A is 2, B is 7, and C is -1. So, if I do B squared minus 4AC, I'm going to get 7 squared minus 4 times 2 times -1. 7 squared is 49, minus 4 times 2 times -1 is +8. 49 plus 8 is 57, and 57 is greater than 0. So if we look up to see what greater than 0 means, that's this one. It means we have two solutions and they're both real. So we're going to want to write two real solutions and box our answer. And that is how you use the discriminant to determine the amount of zeros or the amount of answers and if they are real or non-real. All right, so that concludes 1.4. I hope you all are keeping warm during this snowstorm, and I can't wait to see you again. Have a good day. Bye.